Hello there, and welcome to a new Digital Foundry analysis, taking a look at, I guess, what is our first experience of FSR Redstone. A machine learning-based Ray Regeneration feature has been added to Call of Duty Black Ops 7. And obviously there's going to be comparisons here with what NVIDIA is doing with DLSS, but as you shall discover, there's a few wrinkles along the way. The man who has actually done the heavy lifting here, i.e. all the work, is Alex Battaglia. Hello.
Yes, there, Rich. I've spent the last couple of days looking at this technology after it launched at the end of last week, and I've got a lot to say.
Yes, and not all of it is good, but I think first of all we need to talk about the way that Ray Regeneration has been implemented into Black Ops 7, because I'm looking at your notes here, and my summary of those notes would be one word: weird.
Yeah, it's strange. One, adding into Black Ops 7 and having it only apply to the multiplayer zombie portion of the game, that's a little bit weird in general. Like it's only in one part of the game and not in the other.
Yep.
But as for testing purposes and also just general like user experience, it's a little bit weird having it in a multiplayer title in the multiplayer component only. For reviewers like us, it's hard to actually get the recordings. For all this footage here, I limit myself to the training map, which still requires you to connect to a server. And it requires you to move about every 30 seconds or so. Otherwise, it kicks you from that server.
Right. Okay.
Yeah. So it was not very easy to get these recordings. Another reason why this is not like the best way to maybe debut this technology is because it's only covering one aspect of the denoising paradigm. It's only covering reflections. And the reflections are kind of interesting, actually. They are like multi-bounce, so you can see reflections in them. But it's, Ray Reconstruction from the NVIDIA side, or things like NRD or any of the other larger scale denoisers also cover other aspects of ray tracing denoising, including like direct shadows, direct lighting, indirect diffuse lighting. And with this implementation of Ray Regeneration here in Black Ops 7, we're only seeing reflections. So we're not actually getting a full picture.
Right. Okay.
Yeah.
And on top of that, there's other stuff as well. For example, and the thing that really sticks out to me here, on the same settings, the game can present differently on NVIDIA and AMD GPUs, right?
I don't know what this is about. I've reinstalled drivers both for AMD and NVIDIA here because I don't know what I'm looking at necessarily. But just like look at this scene here in the training map. I flip back and forth between them, and you'll see like, hey, wait, why is this like one image darker? Why is one lighter? And it has to do with like shadows as well as some of the post-processing and reproduction. And if you like zoom in a corner, you'll see that the distance at which shadows renders at the same settings are actually different. And I don't know what's causing that. Then like in another scene here, you can see that the way shadows are rendered entirely is different. They have like, they're more opaque, right, in some sense on the AMD side, and they're darker on the NVIDIA side. I don't know why this is the case, but we're not seeing the same one-to-one visuals here when I look at this game, as well as the ray tracing itself is different between the vendors. In this scene here from that training map, you'll see that there are reflections of lights on the floor that just aren't there on the AMD side. And another similar area of that map, once again, more missing lights on the AMD side, as well as the decals on the wall showing like lettering and whatnot for this cool little sci-fi area. Yeah, they're missing there too on the AMD side. So we're not getting really one-to-one comparisons here as much as I would like. So sometimes you'll see maybe differences in the comparisons I show, and it could be chalked up to differences or just buggy visuals in general. Like, I just don't know.
Yeah. Okay, yeah, and there's other things as well, because, well, obviously, when you're looking at that kind of evidence, it kind of suggests that doing like-for-like benchmarks between NVIDIA and AMD probably not a good idea, because ultimately they're not rendering the same things. But let's talk more specifically about FSR Ray Regeneration, because, going into this, it would be, you'd kind of think that Ray Regeneration is essentially AMD's answer to DLSS Ray Reconstruction, right? However, it's not quite that cut and dried, is it?
No, I think here in a little way, it's a little bit like FSR 1.0 versus DLSS 2.0. And I don't mean to say that as like a negative way. Rather, we're kind of looking at two different approaches. I'm actually not sure if this is the nth degree goal of what AMD actually wants Redstone's Ray Regeneration tech to be. And I think the way you can see that is if you just look in the menu with Ray Regeneration on, it doesn't require FSR 4. It doesn't require it at all. You can turn on FSR 3, you can turn on XESS, you can turn on the game's TAA, I guess. I only tried it with FSR 3. And as you can see here, there's differences in image quality between these two versions.
Right. Okay.
Ray Regeneration with FSR 3, Ray Regeneration with FSR 4. And this is actually very different than what NVIDIA does, where when you turn on Ray Reconstruction, it turns on an entirely different and much heavier algorithm that combines the upscaling step with the denoising step. And that has a number of advantages for performance as well as visuals. And you can kind of see what I mean by that when you compare Ray Reconstruction on the NVIDIA side versus AMD for things that are highly mirror-like.
Right.
Like here on this puddle on the ground. I want you to focus on like this one edge here that I've highlighted. On the Ray Regeneration side, you can see like the internal 1080p resolution here from 4K performance mode, FSR 4 here, versus on the NVIDIA side, it's more like a straight anti-aliased 4K edge. And that has some repercussions. It's a lot more like older denoising tech visually than it is like something that we expected from a Ray Reconstruction competitor.
Okay, so just to sort of boil it down to a more sort of simple take, it's like Ray Reconstruction is not just a denoiser, but also an upscaler for ray traced effects, right? Because
yes.
Obviously, if you don't have that upscaling effect, you've got like, everything else is upscaled, but the reflections or whatever is being reconstructed with Ray Reconstruction would still be at a lower resolution. So Ray Reconstruction is also upscaling, but what we're seeing here with FSR for Ray Regeneration, there doesn't seem to be that upscaling step, which kind of explains why it seems to be operating also as an option with FSR 3 or TAA or XESS, right?
Yeah, and a really good example of that you can find, and I saw Daniel Owen pointed this out as well, and so did Computer Base, is that the reflections on the water look very different between Ray Reconstruction at the same resolution as Ray Regeneration, and like you can see in this example here, it just like they look a lot softer and lower res. And I saw some speculation online like, oh, is one representing water more realistically than the other? And the answer is
right.
No. Ray Regeneration doesn't appear to be doing the upscaling of the ray tracing effect like Ray Reconstruction does. You can see that difference if you turn up Ray Regeneration's internal resolution to native, for example, 4K FSR 4 native resolution, and you put them all side by side. Left 4K performance mode FSR 4, in the middle 4K FSR 4 native, and then Ray Reconstruction at internal 1080p there. And you'll see that the 4K native version of Ray Regeneration looks a lot closer in sharpness, much like DLSS 4 Ray Reconstruction. And I think that's what we're seeing here is this, it's actually doing a lot of the work, and the output is still like at the internal resolution that it's actually rendered at 1080p. So when I'm comparing here, it almost feels a little unfair because I don't think these technologies are actually doing the same thing, which is really strange.
Okay, so I'm kind of reminded of the debut of FSR 3 frame generation here, where we had like what you might call a proof of concept. It worked. It was integrated into a couple of games in that case, but it wasn't the final thing, right? It wasn't the technology that we have today. It was a preview of sorts even, with certain limitations. Now, we don't actually know whether that's the case here because we haven't really had a huge amount of messaging from AMD, but it does kind of feel like a work in progress rendition, right?
Yeah, there's a couple things that give me that feeling from the visual feature set. Now, one thing that reflections do on semi-glossy surfaces, or rougher reflections as you call them, is that when you look at the bottom of the reflection where it meets the object, it's very sharp, and then it starts to get more diffuse as you look along the edge of the reflection as it goes away from the object that it's reflecting. And that's something that seems to be missing in Ray Regeneration. And that's a typical feature of reflections that is reconstructed in the denoising step. That's like, there's so much noise that you have to kind of reconstruct that effect of reflections. And that's missing in Ray Regen in a number of areas that I've looked in. Like, for example, here on the floor, you can see that on the Ray Reconstruction side, it starts off really sharp and then it gets tapered at the end and more diffuse. Whereas on the Ray Regeneration side, it stays sharp the entire length of the reflection. And the same goes in the other direction, where if a surface has a very rough reflection, on the AMD Ray Regeneration side, it's entirely rough, no matter how close it is to the object, like we see here, next to this trash can. Woohoo, trash can. And I love DF. We talk about ray trace toilets and trash cans. This is our job. But yeah, you look here and you can see that it's like entirely blurry, the entire length of the reflection, versus on the Ray Reconstruction side, where it has that contact hardening effect that you expect. So missing stuff like that, in combination with the fact that it doesn't appear to be a combination upscaler denoiser, makes me think this is not a complete product.
Did you want to talk a bit about quality and performance here? Because there's some points we need to go through there, right?
Yeah, sure. So there's some stuff that I think will change over time with this. One thing that I want to point out that it does really well at the moment is moving objects and reflections, as well as animated billboards and reflections. This training level has a number of sci-fi billboards in them, and there's some very like either water reflections on the ground or just very reflective surfaces like metal floors, and in them you can see the reflections of these billboards in them. On the Ray Reconstruction side, they're much higher res looking. That's because I think that's the way it is. But you'll notice that the detail in the reflection will have ghosty areas where the detail resolves over multiple frames incorrectly. Whereas on the Ray Regeneration side, in spite of it being lower res, it's holding it at least without the ghosting. And that looks quite a bit better, I would say, for that aspect. And it does that really well. Mm-hmm. Another thing that it does quite a bit better is some moving objects and reflections on like more glossy surfaces. You can see like here, there's this weird rotating dial in the middle of the map. And one of those rotating features of it, when you look at its reflection on the ground, you'll see in the Ray Regeneration side versus Ray Reconstruction that it holds its silhouette better and it doesn't blur it or ghost it away a bit. And that's something that it does really, really well. So it's handling motion quite a bit well for those things. But at the same time, some other motion aspects are not as good. For example, disocclusion. Like you can see that on the water in the training map, where when you move your gun out of the way, on the Ray Regeneration side, it shows like the silhouette of the gun in like a blurry detail form there for quite a number of frames after the gun's moved away. So it does movement pretty okay, but disocclusion seems to be very work in progress at the moment, to say the least.
Okay. Mm-hmm. Yeah. Performance, frame rates. There's obviously a computational hit to Ray Regeneration, right?
Yeah, and also no. And I'm not the only one who's measured this. I looked at computer-based to double check to see I wasn't going crazy. But if you look at the game's benchmark and turn off Ray Regeneration and the game's base denoiser, like you compare the two in terms of performance, you'll see that Ray Regeneration costs more or less the exact same as the game's base denoiser. It's about 1 frame per second difference between these two benchmark runs. Okay. And I ran it like 3 or 4 times. So the average cost is the same as the game's base denoiser, more or less. And the weird thing too is I also checked out whether or not turning on FSR 4 with Ray Regeneration would have a different performance than FSR 3 with Ray Regeneration, and they actually ran more or less the same too, which is interesting. I guess that points to some other bottlenecking occurring in the architecture that is keeping the performance much the same. But once again, computer base also found at the resolutions they tested that the performance between the denoiser and Ray Regeneration was more or less the exact same. So I'm not alone.
Interesting. Yeah. Well, you would kind of hope that machine learning based denoiser would be like, as performant as the basic one that's of a lower quality, right?
Yeah. in that case, that is a job well done, and you'd want to keep them within the same amount so that you, at least when the quality improves over time with like different network weights and whatnot, and just better training, that you get a much better image for this relatively similar cost, which is the nth degree goal for this project, I assume, after they get past this initial almost beta looking phase of it.
Okay, right, fair enough. Any final thoughts before we wrap up?
Yeah, I think this is altogether a very strange way to demo this exciting new technology. It's going to be part of the next PlayStation, probably part of the next Xbox, and the way it's kind of pushed out on PC right now seems like it was pushed out when it wasn't ready yet, and perhaps before even internally the engineering team might have said, oh yeah, it's like feature complete, because a lot of the stuff here doesn't seem like it's feature complete, like the lack of contact hardening and whatnot. Also, being pushed as a part of like multiplayer only Call of Duty, on top of like the visual bugs in the generic Call of Duty graphics between vendors, makes me think that this entire thing is a bit questionable. Like, I'm not sure if the things I'm seeing are bugs or just the state of the product as it is right now. So that's always not a good thing. I also maybe would have loved a little bit more internal information from an AMD and like a blog post about how it works and what to expect of the technology. But at the moment, it's just mainly what you see visually on screen and then doing the comparisons by yourself. So yeah.
General puzzlement, really, isn't it? If this...
Yeah, I didn't know what to make of it when it launched because I only heard about it via a tweet. And I was like, what?
Right.
What?
Yes.
This game has ray tracing and it has the first part of FSR Redstone. And lo and behold, it did. But I didn't really know about that until like quite late. So that's the way it is.
It's very, very strange. It's a bit of a bizarre product debut, but there it is. And I guess we're not going to be doing huge, more in-depth testing on this because, well, two reasons. First of all, it doesn't seem to be the final product. And secondly, we can't. No. Basically, there's a lot of bizarre stuff happening here. The fact that you can't use it in the campaign is just kind of baffling. I'm wondering if it's an art issue or something like that. But yeah, just general strangeness. But I guess we're just going to have to wait and see what further FSR Redstone disclosures will happen and new game integrations to actually get a better feel for what AMD is trying to achieve here.
Mm-hmm. Yeah, I think if it comes to more games as well as coming to like more path tracing titles where we can see more of its performance for other aspects of image lighting, then we'll have a better understanding of it. And just like, DLSS Ray Reconstruction, when the original 3.5 version came out, we talked about how it had like this smudgy ghosting look that improved over time with other versions, as well as the changeover to transformer model. I think we're going to see a very similar trajectory with Ray Regeneration when the time comes.
Okay, good stuff. Well, that's all we got for this one. But if you enjoyed the content, please do like, subscribe, share, ring bells for notifications for you. Alleged potential algorithmic boosts for us. But really, it's all about the DF supporter program. Join us, patreon.com/Digital Foundry. And do check out our brand new website at digitalfoundry.net. But that's all from us on this one. Thanks for watching and supporting Digital Foundry.